constantly being added to out here on the periphery, and the surface is just being pulled in and sucked down the whole into the past. Okay, so that's just a cartoon of this. Okay, next. Okay. So what about time and space? Can we visit the past or the future? Can we interact with it? Yes, you can visit the past and the future, but not in the sense that you're thinking of. It's not that you climb in a time machine and your body goes to the past and the future. You can go into the future probable database. And how do you do that? Well, you query this database like you query any database. You have to have specific. The more specific your query, the better data you get back. If you go up to Google and you give them a very non-specific query, like you go to Google and you put in love, hit the button, you get 6 billion replies back, right? And you can't find anything you want because it's too general. You go and you hit dogs, you'll get too much back. But if you get real specific, then you'll get very specific information back. Well, this database works the same way. And how do you query it? You query it with your intent. This is consciousness. You are consciousness. Intent in consciousness is what modifies the data. It's your intent. That's the motive force in consciousness, is intent. So you can go into this database with a very specific intent, and you can get the data. Now, another thing you have to learn is that when you get that data, you have to specify the output format. Otherwise, whatever you don't specify comes out like with random decision. It's like if you send a letter to somebody and all you do is specify the state, you don't have a lot of probability of getting there, right? Because you don't have enough information. You're not specific enough. You have to do the state and the city and the street and the number, and then you've got it. So if you don't specify any of those things, you can only get so far. And after that, if you only give it the state and the city, then it's random after that. It'll go get you something. It always returns something for your intent. But once it gets to the city and it doesn't know what the street is, it'll just go randomly pull something from some street somewhere, and that's what you'll get. You get the random information at the end. So if you have to be very specific about what you want, but it's intent is what controls consciousness. It's intent that lets you travel. It's intent that tells where you go. It's intent that heals. It's intent that modifies this reality. Intent is the motive force in consciousness. That's consciousness expressing itself. That's consciousness expressing its will. That's what changes things. So you can get to the future, but when you're in that future, here you are in a database that has everything that possibly could happen. That's not just necessarily everything that will happen. It's just what could happen. And it's not even necessarily the most probable thing that could happen. That's just a little thread that runs through that database. It's the highest probability of everything happening. So your intent has to be aware of that too. Or you could get into threads that have very little probability of happening. So you need some control and you need some experience so that you can make sensible queries and specify exactly what you want. Now people get into that all the time. That's a precognitive dream, right? They'll have an experience. It comes true here. Well, they got some data out of that database, but it's mostly uncontrolled stuff. And sometimes it doesn't come true because sometimes it's not that the data was wrong. Sometimes it comes through because you got data, but you didn't get it on the most probable thread. You got it on some other thread. And sometimes it's just things changed if it's very far out. So that's the future problem. So you can get there. You go into the past. Now, all of these databases, and you can go into both the past that was actualized and wasn't actualized. So you can go into the past and you can say, well, if you were, wanted happier days, you could go into the past and say, well, what would happen if we'd never elected George Bush? Or what would have happened if Hitler had won World War II? Or what would have happened if, whatever. You can do those things, go into those databases, and you can follow the line of most likely events down that path, and out'll come the results. Now, would those exact results actually have happened? Well, you don't know because you're not looking at free will choices now. All of those databases are inhabited by models of all the players. Now, what's a model of all the players? Basically, it's your data set. Your data set. Your consciousness is basically a data set. Remember, it's an information system. We're subsystems. We're a chunk of data. We have memory and processing and all that kind of stuff. It's basically your data set without the free will. okay, because it's now in a database. Free will's only in the present. That's where you make choices. So you can get into that, and it's got all the characters in it, and you can intend for it to be the highest probability, and it'll get you a story. And it's just like being in a movie. You can see it, you can live in it, you can walk around in it, you can be in there, you can interface with the characters, you can change things. You know, say, well, what if I change this? Well, when you change that, you basically then start going off down another thread, because if that was changed, what then would be the most probable thing? So you can do all sorts of what-if analysis and use these databases creatively. If you wish, you just have to have the mental discipline to have a clear intent and hold it and understand what you're doing. So yes, you can go to the future, you can go to the past, you can go to the past that happened, the past that didn't happen, the future that's likely to happen, and the future that's very unlikely to happen. You can get into all of those, and you can explore those with your intent. Notice that the future exists in probability and remains that way until somebody does something, right? Well, that's what we were talking about back at that double slit experiment, right? So you have this future probability, and you got that photon in there, you got that electron in there, and it's just going to stay probability until somebody makes a measurement. And once you make a measurement, it's got to come into this reality. And it'll come into this reality in whatever the highest probability is at the time. So that's how it makes that selection. And once it's in that reality, it's here. You have to stay consistent. You can't have things going in and out of reality. You've got a rule set. And the rule set requires consistency. Has to obey the physics. Okay, let's go on. Okay, a value of a theory. Let's talk about theories. The first one, and it's the one that generally is used most, is the one I have struck out there. A theory is valuable if it supports the current scientific beliefs. That's unfortunately true in practice, but it's not really true logically. What makes a theory valuable is it explains what's known. It has to explain everything that we know. Okay? It has to do that in the fewest assumptions possible. If you need a lot of assumptions to prop up your theory is probably not fundamental. It's probably not right either, but it's certainly not fundamental if you've got lots and lots of assumptions. A long time ago, the assumption of the way that the planets and the sun and the moon moved was the angels pushed them. There are angels up there flying and pushing these things around. Well, that was a theory, but it took a whole lot of assumptions to prop it up. There was lots of assumptions. Well, you had angels, and then the angels had to fly, and then they had to push this thing, and who fed the angels, and where did they sleep, and it goes on and on and on and on. How to support these angels, and where did they come from, and what are their work hours, and how hard is it to push the sun, and so you have lots and lots of assumptions that have to build up to support that kind of a theory. And if you have a lot of assumptions, it's probably not right, and it's probably fundamental. You're just making up things, which in science, that reminds me of string theory. String theory is sort of that way. String theory started out, and then they had, I think it was 7 dimensions, and then it was 12 dimensions, it was 14 dimensions, and every time they find a problem or something that doesn't do right, they jiggle it around and come up with another dimension or two to solve that problem and so on. It's got assumption after assumption after assumption is probably not fundamental. It's just a sign of not being fundamental. A sign of being fundamental is simplicity and elegance. That's what nature's made of. Because when you're this system defining this rule set that defines this reality, you don't do that with obtuse complexity. You do that with a few simple rules that then evolve to the bigger, more complex picture. Okay, so it also has to explain what is unknown. Theory is not any good if it all does is explain what you already know. Well, maybe it's good, but it doesn't accomplish much. It's not any better than the theories you already have. So you explain everything that's known, then you have to explain things that are unknown. And after you explain things that are unknown, and you can see my list there, the placebo effect, healing, wave-particle duality, precognitive dreams, UFO experiences, out-of-body, entangled pairs, remote viewing, contact with other physical and non-physical entities, intuition, purpose, spirituality, metaphysics, all that kind of stuff. It also has to provide new insight and predict new information. You have to come up with new things that nobody knew before. Otherwise, it's not a very valuable theory. Like deriving quantum mechanics or or giving a good explanation of how the paranormal works and how healing works with the mind and how precognitive dreams work and all sorts of other things like that. And then the last thing you have to do is to be able to verify that the new information is indeed correct. And that takes experimentation. You have to be able to predict and then verify, then measure and do the experiment. That's a theory that works. Okay, that's a good theory. And the theory that you'll get in My Big Toe covers all 4 of those requirements. Okay, next. Okay, the larger reality system, it's teeming with life. It's evolved. Life, that being consciousness, right, has evolved to fit in every niche, every little crick that there is that can support consciousness supports it. That's why if you have a computer capable of supporting consciousness, the consciousness will just be there. It's not a matter of having to design it and figure out how to build it. It's a matter of being able to support it, having a niche that it can get into. So there's lots of life out there. There's lots of physical reality systems. There's a lot of non-physical reality systems. They're populated by all kinds of beings. And one way to look at this is evolution evolves things to fill what it can support. So you get a real structured system like ours, a physical reality that's quite structured, then the things that can evolve there have to fit within those constraints. So you're limited by the constraints as to what can evolve. You go to a larger reality that's less constrained, and what can evolve there is a much wider set of things. It's not constrained like it is here. So into the larger reality, you have beings and creatures and things and configurations of consciousness and stuff that are much, much wider and broader than here. You run into things that are very different. And as I say in some of my lectures, there's things that are more ugly and more awful and more wonderful and more beautiful than anything that you can imagine here, because it's just fewer constraints. Fewer constraints has more degrees of freedom. More degrees of freedom, you have broader boundaries. These realities are not that hard to get around in. Again, you don't have to leave your body. Your mind already's done that. All you have to do is take control and stop blocking it. All these entities all over, because it's all consciousness, they're all doing the same thing. The system is set up to evolve. There's all sorts of little experiments going on and other things happening in these realities, but everybody's basically on the same purpose. Next. Okay, this is a little higher organization of that. These things I've called NPMR, that's non-physical matter reality, 1, 2, 3. You see those big ones going around here, 1, 2, 3, and then N+1 and N. And this one in the middle, which I'm going to call, sub-N, that's us. Okay, here's our PMR inside the green circle. That's our universe. There's OS. That's the part of the non-physical that interacts with us. And here's the rest of it. Inside here, there's a PMR1, PMR2, and then here we are, PMR3, K, and other things that aren't really PMRs, other reality frames. Now, what is this thing? Well, you can think that almost like a experimental protocol boundary, almost like a political boundary. The kinds of reality frames that are in here serve a similar kind of purpose and have similar kind of rule sets applied to them. You get out into some of these others, and they're just very different. It'd be like the difference between, living here and going to, some place in rural China to live. Everything's different. It's just the rules are different, the customs are different, the creatures are different. It's a little different. Inside of N division, I do that with a corporate, I am very irreverent with all this stuff because it is a system, and I don't want to encourage people to get too carried away with the system. It's an evolving system. So you have different kinds of systems. I kind of see them as experiments in evolution. So you'll have a general idea of how things maybe ought to evolve and what will happen if they do, and the way that you can tweak that experiment, how you can design your virtual reality. Virtual realities, eventually they do evolve, but you can tweak them and change them and do a little bit with them, and you can evolve some that are differently. These big circles are basically different plans for evolution, and they have their own organization. Okay, we're going to talk about virtual realities. Okay, when you generate a virtual reality, whether you're the people making World of Warcraft or whether you're the consciousness system, basically the key idea is conservation of resources, right? In computer talk, that's being parsimonious, with your cycles and with your memory. You need to put as little energy and as little time and effort into the rendering as you can get by with. Okay, minimum effort. Particularly if you have something as big as our whole universe to render, right? Well, how do you do that? In the computer games, your World of Warcraft game, when you suddenly go around a corner, you can see in the background the trees suddenly pop up. There were no trees there, and then suddenly the trees are there. That's because their computer is slow, and their servers are slow compared to the computer that's running our system. So we don't see trees pop up. They don't do that because we have much smaller time increments, and it's a lot faster. But the reason they pop up like that is that the computer game isn't going to produce those trees unless there's somebody there to look at them. If there's no player in the area, the computer isn't going to make trees just because the computer likes making trees. That's a waste of resources. So it only makes trees because there's somebody there who needs to be part, that's part of the scenery that they need to see. So when a person rounds a corner, then the computer gets the message that there's somebody there looking in that direction, produce the trees. Well, that actually works in any virtual reality, and we're going to talk just a little bit about that. So the probable system, remember we talked about future probability, knows what's possible, what's likely, and what's important. Okay, it has some intelligent software in it that knows that whether the decision is to scratch my head with this hand or this hand, that's my decision. It lets that go. That's not a decision that drives anything. So that's not something that you have to calculate out. So it's got some intelligence in the sense that it only calculates things that it judges to be important. And again, this system is not perfect. This system makes mistakes. It's a real system. Not only are real systems never infinite, they're never perfect. Okay, so you have the future probability. So the system knows what's coming, or very close, as far as what needs to be rendered, and who's doing what, where all the characters are, what they're doing, what they're measuring. All of that's known in advance. That's part of the reason why you have a probable future database, is that gives the computer a good head start on what needs to be rendered in the next delta t. All right, let's go on. Now, the handout that I gave you, and some of you may not know about handouts. If you just showed up today and registered at the desk outside, there was some material that I handed out, and you can get that by going to www.mbtevents.com. That's Keith and Donna's website, and just downloading it. It'll help you fill in some of the details of what I'm not going to say today, and those of you who read it, you'll remember this. One of the examples there was an example that I called Planet Z. Planet Z has all of its beings living on one continent. There's just two continents on this planet, and they're on opposite sides of the planet. All the people live on one, and on the other are all the trees that provide the oxygen. Okay? Now, do those trees have to be rendered? No. There's nobody taking a measurement. We'll assume for right now there's no bugs or critters living in the trees. Okay, we'll get to that in a moment. They don't have to be rendered. Well, they don't have to be rendered. What are the people going to breathe? Well, you're habituated to your thinking in physical terms. The people don't have to breathe oxygen. It only has to be probable that there's oxygen that they breathe. It only has to be probable that there's trees growing over there. Okay? So they get by just fine on probable oxygen. Now think of your World of Warcraft game. You have a character there, and do all those characters have to have oxygen? No, you say, that's silly. They're just computer characters. They don't have to have oxygen. They're just That's just a virtual reality. Well, so is this, and we're no different. We don't need oxygen any more than they need oxygen. Okay, but now what about that World of Warcraft? If one of those critters, I remember my son first started one of those games and he had a lizard man that fell in the water and he didn't know how to make it swim and it drowned. Well, it seems like they did need oxygen. So those characters, they drown if they fall in the water, they get hurt if they fall off of cliffs, all those things happen. But, where's the mass to provide the gravity? Where's the oxygen in the game? Well, it's just modeled that way. In virtual reality, you just have to model the end effect. You don't have to model the details. So when these people are all living on one side of the planet, as long as the probability that's been computed for this reality says that there's likely to be trees on the other side, then there's no problem breathing. They can breathe that likely oxygen. Now, once they get a laboratory where they get to isolate oxygen as an element and actually see oxygen, then oxygen has to be rendered. But when they're not looking at oxygen, oxygen doesn't have to be rendered. So you walk outside and you look at the stars and you're saying, wow, that's an awful lot of data to render, all the billions of stars and all the dust and all the, well, all that has to be rendered to you is a little spot of light. That's easy. That's all you need. It's just a little spot of light at about the right intensity. All that has to be rendered for you. Now, if there's somebody else at the same time looking through a telescope who can see all that swirls of gas and the rings around Saturn and so on, then you can't render just a spot for them. For them, you have to render what they would see, what is probable for them to see. So each of us only needs our character playing in the game, only needs to have rendered to it, what we're measuring, what we're seeing, the data that we're collecting. So now suddenly the requirement for this computer, you're thinking, how could a computer do this whole universe? That's just too much data and whatever. Well, it doesn't have to. You only get what's rendered to you, what it is you need to know for the measurements you're making. If you're not making any measurements, in other words, you're lying in bed with your eyes shut, then it doesn't have to render anything to your visual part. There's nothing there to render. You don't need anything rendered. Now, that doesn't mean that because